The bobbit worm is buried beneath tropical sand with only 5 thin antennae exposed. Most of its body can remain underground. Then a fish passes over the wrong patch of seafloor. The sand opens. The fish is gone before the water has time to settle. The animal is usually called the bobbit worm. Its scientific name is unsuspecting. It is not a snake, it is not an eel, it is a marine bristleworm. And beneath the sand, it can grow to nearly 3 meters long. That length is difficult to see because the worm does not display it. Most of the body stays hidden in a burrow. Only the head is exposed. At first, it can look like a small dark flower in the sediment. 5 antennae extend into the water. They move slightly with the current. They are not decoration, they are tripwires. The body behind them is divided into many segments. Each segment carries small bristles and fleshy paddles called parapodia. These help the worm move through its tunnel. They also give its body a disturbing texture. It does not slide through sand like a snake. It grips, it braces, it pulls itself through its own buried corridor. At the front are the jaws. They are dark, hard, curved like a pair of small blades. Most of the time they remain hidden inside a muscular throat. Then the throat turns outward, the jaws appear, and the head becomes a weapon. The impossible part is not that a worm has teeth. It is that the teeth are attached to an animal you may never see until they have already struck. The bobbit worm is not an abyssal animal. It does not need kilometers of black water above it. It lives in warmer seas, often around coral reefs, rocky ground, and sandy or muddy sediment in the Indo-Pacific and Atlantic. Some live in relatively shallow water. Others occur much deeper. But its preferred darkness is often created by the seafloor itself, by sand, by rubble, by the shadow beneath coral. At night, a reef becomes a different place. Dayfish disappear into crevices, crustaceans emerge, small fish move closer to the bottom. The water may still hold moonlight above, but close to the sediment there are blind spots. A fish can pass over open sand and believe it is safe. The bobbit worm turns that assumption into an advantage. Its burrow is more than shelter. It is an engineered hunting position. The worm strengthens the inside with mucus. It holds the walls together. It creates a long, narrow passage where the body can retreat after a strike. The entrance may be almost invisible. A thin ring in the sand. A small disturbance. A few antennae touching the water. Then nothing. The worm can wait for hours, perhaps longer. It does not patrol the reef. It does not waste energy chasing animals that may never be caught. It lets the reef come to it. And every animal that swims low enough is entering the range of something hidden beneath the floor. The antennae sense movement. A fish does not have to touch them directly. Changes in water flow can matter. A nearby body sends pressure waves through the water. A swimming tail creates vibration. A struggling shrimp creates disturbance. The worm waits until that signal is close enough. Then it strikes upward. The movement is so fast that it is often described as an explosion from the sand, but the worm does not simply bite and let go. Its jaws close around prey. The body bends. The buried muscles pull backward, and the target is dragged down toward the burrow. Small prey may vanish whole. Larger prey can be injured badly enough that escape becomes difficult. Some accounts describe fish being cut in two. That can happen when a fish meets the jaws at the wrong angle. But the more disturbing outcome is often quieter. The fish remains alive. The worm pulls it below the surface. The sand closes over the struggle. Then the reef continues. The worm's jaws are not its only tool. Its head can extend forward with a section of the throat. This gives the strike extra reach. The body remains buried. The mouth comes out to meet the prey. It is like a trap that can briefly leave its own hiding place. There is no warning posture, no visible preparation. One moment, the seafloor is still. The next, it has teeth. The bobbit worm's real weapon is not speed alone. It is the difference between what prey sees and what is actually there. A fish sees open sediment. The worm sees a feeding lane. A shrimp sees a place to cross. The worm sees a signal passing over its antennae. The reef is full of predators that announce themselves. Lionfish have fins. Moray eels have heads in holes. Groupers have large bodies and obvious mouths. The bobbit worm has almost none of that. It hides the body. It hides the mouth. It hides the scale. A worm 2 meters long can be living beneath a small area of sand. The fish above it may only see 5 antennae. This is why the animal is so effective in aquariums. A young worm can arrive hidden inside live rock or reef material. At first, it may be too small to notice. Fish begin to disappear. A shrimp vanishes, then another. The tank is searched, filters are checked, the water is tested. Nothing explains the missing animals. Meanwhile, the worm grows beneath the rockwork. It feeds at night. It retreats before the lights return. In 2009, one large unicid worm was removed from an aquarium in the United Kingdom after years of unexplained losses. It had lived hidden in the system long enough to become far larger than anyone expected. The human-built reef had become a burrowed hunting ground. That is the wait. What moment? The predator does not need to enter a tank. It can arrive first and remain invisible while everything else disappears around it. The name Bobbit worm is not a scientific name. It is a popular label. Its origin is uncertain, and the story often repeated about it is more famous than useful. The biology is strange enough without it. Scientists have also warned that animals called bobbit worms may not all belong to one neatly defined species. Large unicid worms can look similar. Their colors vary. Their bodies can be difficult to identify after collection. DNA studies have shown that the category is not as simple as the internet makes it sound. But the hunting method is real, the burrow is real, the jaws are real, and this strategy is old. In Taiwan, scientists found fossil burrows from around 20 million years ago that resemble the hunting tunnels of large ambush predatory worms. The burrows are L-shaped. One section descends into sediment, another runs horizontally below it. Around the upper entrance, the fossil shows repeated collapse marks. The researchers suggested that prey struggling during an attack may have caused the sand to cave inward. The ancient seafloor kept the shape of the ambush, not the worm, not the fish. Only the evidence that something had waited below. That is how little an ambush predator needs to leave behind. A tunnel, a disturbance, a vanished body, and a pattern in stone that says the sand was dangerous long before humans learned to dive over it. Human encounters with bobbit worms are rarely planned. They are discovered after a problem has already started. Divers may spot one head emerging from a reef at night. Aquarium keepers may find one after months of missing livestock. Researchers may collect a specimen only after it is pulled from sediment or rock. The worm almost always wins the first part of the encounter. It sees the disturbance, it feels the vibration, it retreats. The rest of the body disappears into a hole too narrow to inspect. Removing one can be difficult. Pulling too hard can tear the worm. Breaking rock apart may damage the aquarium or reef habitat around it. And because the animal can retreat so deeply, the exact length may remain unknown until it is finally removed. The most unsettling footage is often not the strike, it is the waiting. The worm holds position with its head above the sand. The antennae drift, the jaws remain hidden. Nothing moves for a long time. Then a small fish crosses the frame. The image changes too quickly to follow. The fish is caught, the worm drops backward, and the sand becomes empty again. The source of the attack has returned below the surface. This is not a creature that needs to dominate a reef by being seen. It dominates by being underestimated. A shark controls water around it. A bobbit worm controls one small piece of ground, and it can make that small piece of ground fatal. We still do not know enough about the lives of these worms. How far do they travel before choosing a place to build a burrow? How long can one individual remain in the same tunnel? How often does it feed when prey is scarce? How many animals called bobbit worms are different species hiding behind the same common name? We know they can be large. We know they can wait. We know their jaws can strike with enough force to seize fish, crustaceans, and other worms, but most of their lives take place below a surface that hides everything important. The body, the tunnel, the remains of prey, the moments between attacks. A bobbit worm does not need the darkness of the abyss. It creates its own darkness beneath a few centimeters of sand, and when the next creature rises from the seafloor, it may not be buried at all. It may already be moving beneath the water beside you.